We're now going to solve another type of exponential equation. This one will require us to use some of the properties of logs. We have 2 to the x power equals 5. Our goal is to get this exponent of x out of the exponent as a coefficient. Recall, one of the properties of logs states that if we have log to the base a of m to the r power, we can take that r out in front as a coefficient of the logarithm and get r times log to the base a of m. So we're going to use this same theory in solving this particular equation. The base a that we choose can be any value that we desire. However, some choices might work better than others. For example, suppose that I write this as log to the base 2 of 2 to the x power, so that I choose my base to be 2. Then on the right hand side I get log to the base 2 of 5. Now the exponent x can come out in front as a coefficient, and I get x times log to the base 2 of 2 equals log to the base 2 of 5. Log to the base 2 of 2, you should recall, is going to equal 1. Log to the base a of any number a equals 1. So now I get that x equals log to the base 2 of 5, and that answer is exact. Now suppose instead that I didn't use log to the base 2 to solve this problem. What would happen instead? Well, so suppose instead I decided, you know what, I think I'm going to take the natural log of both sides of the equation. Well, then I get the natural log of 2 to the x equals the natural log of 5. Again, the x comes out in front as a coefficient. I get x times the natural log of 2 equals the natural log of 5. I divide both sides by the natural log of 2, and I get the natural log of 5 divided by the natural log of 2. And that answer is also correct. Recall, in the other way we did this, I had x equals log base 2 of 5. But by the change of base formula, I could write that as natural log 5 over the natural log of 2. The moral of the story is this: no matter what base you choose, the procedure will work. All the answers will be equivalent.
We've now seen how we can solve an exponential equation algebraically to get exact solutions. Now let's look at how we can use a graphing utility to get approximate solutions to that same equation. We want to solve the equation 2 to the x equals 5. We have two options. We can use the 0 feature on our calculator or the intersect feature to solve this equation. Since we have two non-zero expressions on either side of our equation, we'll use the intersect feature. We'll go ahead to our graphing calculator. We're going to graph the left side of our equation in y1, or enter the left side in y1. That's 2 to the x power. Enter. And then we'll put the right side in y2. That was 5. We're going to graph that on our standard viewing window. Here we have the graph of 2 to the x, and then we get the graph of y equals 5. We're looking for the intersection point, which occurs, looks like, between 2 and 3. To find the intersection point, we go to our calc menu. So we do second and trace. Pick option number 5 for intersect. For the first curve, we're on y1, so we'll press enter. The second curve, we're on y2, hit enter again. And for our guess, it looks like it's between 2 and 3, so we'll use 2.5 for our guess. Hit enter. And it turns out that intersection point is approximately 2.32, comma 5. Go ahead and drag this over. Now, when solving equations using intersection points, it's the x-coordinate of the intersection point that's a solution to our equation. So in this particular case, the approximate solution to our equation is x approximately 2.322. When we did it algebraically, we were able to find an exact solution we use our graphing utility, we can only get an approximate solution in this case.